In this video, I'm going to teach you how to convert fractions to decimals. I'm going to teach you two techniques, two ways of doing it. The first one works in some of the cases. The other one works in all cases, but it's worth knowing both of them because it may help you in the future. So let's start. We're going to start with 1/2, 1/2. So we want to know how to write half as a decimal. In the first technique, we need to find the smallest of these three, 10, 100, and 1000. Which one of these three is the smallest who can be divided by the denominator? (10, 100, or 1000? So in this case, it's very simple. We know that 2 times 5 is 10, so we'll pick 10. We use 2 times 5 in the denominator, and the exact thing we'll do to the numerator. So we multiplied 2 by 5, we'll multiply 1 by 5. And we get 5/10. Now we write 0 point something because 5 is less than 10. So it's obviously 0 point something. And we put placeholder. In this case, we put only one placeholder because the number that we chose, which is 10, has only one 0. The number of zeros determines the number of placeholders. So if we chose 100, we would have 2 placeholders, which we would need to fill with numbers. So again, in this case, we chose 10, so it's only one placeholder, and then we place the numerator right here. And we get that 1/2 equals to 0.5. Let's see the second example. 1/5, 1/5. Which one of these three is a multiplication of 5? Which one of these can be divided evenly by 5? The smallest of these three. It's obviously 10. 5 times 2 is 10, so we'll pick 10 again. And again, we write 5/2 in the denominator, and the same number that we multiplied the denominator, we multiply the numerator, and we get 2/10. 2 is smaller than 10, so we write 0 point something, and 10 has only one 0, so we write placeholder here, and we place the numerator right here, and we got the answer. 0.2 is actually 1/5. Again, very simple. What do we do here? 3/4, 3/4. Which one do we choose now? Obviously 10 cannot be divided evenly by 4, so we take 100, and it's 4 times 25. We write it here, and we multiply the numerator by 25. And we get 75/100. Again, the 100 has 2 zeros, so we put 2 placeholders, and we place the numerator right there. And we get that 0.75 is 3/4, 3/4. Fraction, decimal. Very simple. Let's see another example, 2/25. 10 cannot be divided by 25. It's smaller than 25. So let's try 100. And 25 by 4 is 100. So we pick this one. And we multiply 25 by 4 and the 2 by 4. We will perform the same action on the denominator and on the numerator. And we get 8 over 100. 8 is smaller than 100. So we write 0 point, and since 100 has 2 zeros, we put 2 placeholders. But what do we do now? If we put the 8 here, it won't be true. So if you have more placeholders than digits in the numerator, you start placing the numerator from the right-hand side. So in this case, you place the 8 here, and the rest of the placeholders are filled with zeros. In this case, we have only one placeholder, which will be empty, so we fill it with a 0. So we write 8 and a 0, and the answer is 0.08. So we start filling the placeholders from the right to the left. And we get that 2 over 25 is 0.08. Let's see how we deal with 1/3, 1 over 3. Well, 10 cannot be divided by 3. And 100 cannot be divided by 3. Nor can 1,000. So what do? You remember at the beginning of the lesson, I told you that I'm going to teach you a second technique, which works in every case. So let's see how we do it. The solution for this, the second technique, is using long division. We multiply the numerator by the denominator. But hey, how can you do that? I mean, I cannot divide 1 by 3, right? Well, there's a trick. First of all, we say, okay, 1 is smaller than 3. So we write 0, 0 point something. And then we change the 1 into 10. We add a 0 to it. 10 can be divided by 3, not evenly. We'll have a remainder, but it's very useful. Let's see how we do that. 10 divided by 3 is 3. 3 times 3 is 9. We subtract. We get 1. 1 is smaller than 3, so we add a 0 to it. 10 divided by 3 is 3 again. 3 times 3 is 9. We're left with a 1, smaller than 3. Add a 0. And what's going on here? We keep getting 3, 3, 3, and it goes on forever. 10, 9, 10, 9. This will go on forever. It's infinitive. It's recurring. This digit is recurring. So since we don't want to waste too much time, we have a way to mark it. We write 0.3, and above the recurring digit, we put a sign that tells us that this is a recurring digit, repeating digit. And we get that 1/3, 1 over 3 is 0.3, and only the 3 is recurring. And this technique works in all cases. Now let's see it in other cases, other examples. 1 over 9. Again, it cannot be 9 is not a multiplication of 10, no 100, neither 1,000. So, again, we use the second technique. Long division. 1 cannot be divided by 9, so we write 0 point something and we add a 0 to the 1. 10 divided by 9. That's 1. 1 times 9 is 9. And we're left with 1. It's smaller than 9, so we add 0. We get 1 again. And again, and again, and again. This is also a recurring decimal. The 1 will go on forever, you see. 10, 9, 10, 9. We just mark it with 0.1 and put a sign on the 1. This gives us 1 over 9, which is 0.1, and the 1 is recurring. Let's see what we do with 1 over 6. I'll skip the part, the 10, 100, and 1000, because none of them can be divided evenly by 6. And I'll use long division again. 1 is smaller than 6, so it's 0 point something. And we add a 0 to the 1, and we get 10 divided by 6, which is 1. 1 times 6 is 6, and we're left with a 4. 4 is too small, so we add a 0. 40 divided by 6 is 6. 6 times 6 is 36. And we subtract. And again, it's smaller than 6, so we add a 0. And it's 6 again. And 6 times 6 is 36. And this one goes forever again. Only in this case, it started in the second digit. So we'll have 0.1666 forever. Only the 6 is recurring, not the 1. So we have 0.16, and we put the recurring sign only on the 6. Because the 1 is not recurring. It appears only once. And we get that 1 over 6, or 1/6, is 0.16 with a recurring 6. 1 over 11. What do we do with this? Yeah, we'll skip this one as well. We know that they cannot be divided by 11. So we use long division, 0 point something. 10 still cannot be divided by 11, so we add another 0 here. And we change this to 100, which can be divided by 11. Not evenly, but it can be divided with a remainder, which is 9. 9 times 11 is 99, and we get a 1. We get a 0, still not good enough, so we write 0 here. And we add another 0. 100 divided by 11 is 9, and we have a repeating pattern again. And this one goes forever. So I think you got the point by now. So we write it like this: 0.09, and as you can see, 0909. So in this case, 2 digits are recurring, both the 0 and the 9. This is how you mark it. You put the recurring sign over the repeating digits. And we get that 1 over 11 is 0.09, where the 0 and 9 are recurring. So, in this lesson, we learned how to convert fractions to decimals. We learned how to convert 1/2 to 0.5, and that 1 over 5 is 0.2, and that 3/4 is 0.75, and that 2 over 25 is 0.08. And we also learned about recurring decimals. 1/3 is 0.3, recurring sign on the 3. 1/9 is 0.1, recurring 1. 1/6 is 0.16, where only the 6 is recurring. And 1/11 is 0.09, where both the 0 and the 9 are recurring. See you in the next lesson. In this lesson, I'm going to teach you how to convert decimals to fractions. For that, we have to remember a few basics and then we'll move on. So you have to remember by heart that 0.1 equals 1/10, 1/10. And that 0.01 equals 1/100. And that 0.001 equals 1/1000. And it goes on and on and on. 0.0001 equals 1/10,000. But we won't get to that. These three are enough. So you have to remember them by heart and to know to convert from the left side to the right side and vice versa. And these will appear on the screen during most of this lesson. Now let's see an example. 0.7, we want to know how to write it as a simplified fraction. The 7 here appears as the first digit after the decimal point. That means that is the times we multiply it by 1/10. So in this case, we have 7 times 1/10, which is 7/10. So 0.7 is 7/10. Let's see another example. 0.4. That's 4 times 1/10. 4 times 1/10. However, in this case, both the 4 and the 10 are even numbers, so we can divide them by 2. If you perform the same action on the numerator and on the denominator, you do not change the value of the fraction. You just change the way it looks. You change its representation, but the value remains the same. And when your teachers ask you to convert a decimal to a fraction, they mean that you need to provide them with the simplified fraction. So if your teacher asks you how to convert 0.4, if you tell them 4/10, it's the right answer, but they may reduce points to you because this is not the simplified fraction. The simplified version is 2/5. Divided the 4 by 2 and the 10 by 2. This is the simplified version. This is what you are expected to provide when someone asks you to convert a decimal to a fraction. Although 2/5 equals 4/10, the simplified version is the one that you need. Simplified fraction. So 0.4 is 2/5. Let's see some more examples. 0.23. Since we have 2 digits here, the first one is the times we multiply it by 1/10, and the second is the times that we multiply it by 1/100. So it's 2/10, that's for the first digit, and 3/100. That's 2 times 10 over 10 times 10. We multiplied this fraction here. We multiplied by 10 and divided it by 10. Again, if you perform the same action on the numerator and on the denominator, you don't change the value of the fraction. That applies to both multiplication and division. So we multiply them both by 10, and we didn't change the value of the fraction. The 3 over 100 stays the same. The reason that we multiplied it is that we want to get the same denominator, 100. So we have 20 over 100 plus 3 over 100, which is 23 over 100. You could have seen that immediately from here. 2 digits, that means just this number over 100, which is what we get. So if you see a decimal with 2 digits after the decimal point, you immediately know that it's the 2 digits over 100. And if you can simplify it, you must simplify it. In this case, you cannot simplify it because 23 is a prime number. You cannot divide it by anything aside from itself and 1. Let's see another example. 0.48. You already know now that it's 4 over 10 plus 8 over 100. Again, we multiply it by 10 and divide it by 10 and add. That's for the first fraction, and the second one stays the same. And we get 40 over 100 plus 8 over 100, which is 48 over 100. Again, we can do it directly. 48 over, just place the 2 digits over 100. However, we can simplify it, so we must simplify it. Let's divide the 48 by 4 and the 100 by 4, so we don't change the value of the fraction. If you perform the same action on the numerator and on the denominator, you get the same value, which is in this case 12 over 25. So 0.48 equals 12 over 25. And another example, this time with 3 digits. So it's 3 times 1 over 10, and 4 times 1 over 100, and 6 times 1 over 1,000. Or we can also say 346 over 1,000 immediately. This is what we'll get. And again, this is not the simplified version of it. Fix. So we'll divide the numerator and the denominator by 2 and get 173 over 500. This cannot be simplified further. So 0.346 equals 173 over 500. So 0.1 equals 1 over 10. 0.2 equals 2 over 10, which can be simplified to 1 over 5. We divide the 2 by 2 and the 10 by 2. We get 1 over 5. 0.3 is 3 over 10. 0.4 is 4 over 10, which can be simplified by dividing them both by 2, and we get 2 over 5. This is the simplified fraction of 0.4. 0.5, I hope you know it by now. It's 5 over 10, which is 1/2. 5 out of 10 is 1/2. And you get to it by dividing the 5 by 5 and the 10 by 5. 0.6 is 6 over 10. Simplifying it will lead us to 3 over 5. 0.7 is 7 over 10. 0.8 is 8 over 10, which can and should be simplified to 4 over 5 by dividing them both by 2. 8 divided by 2 is 4, and 10 divided by 2 is 5. 0.9 is 9 over 10. Very easy. Let's see some 2 digits. 0.11 equals 11 over 100. Just placing the 2 digits in the numerator, and the denominator is 100. 0.25 is 25 over 100. We can divide them both by 25 and you get a quarter, 1 over 4. This is the simplified fraction. 0.37 is 37 over 100. 37 is a prime number, so we cannot divide it. 0.44 equals 44 by 100, and if we divide them both by 4, you get 11 over 25. This is the simplified fraction of 0.44. 0.54 is 54 over 100. If we divide them both by 2, we get 27 over 50. This is the simplified fraction of 0.54. 0.65 is 65 over 100. If we divide them both by 5, we get 13 over 20. 0.71 equals 71 by 100. 71 is a prime number, so it cannot be divided by anything aside from 71 and 1, which doesn't help us here. So this is the simplified fraction. 0.84 is 84 over 100. If we divide them both by 4, we get 21 over 25. And 0.91 equals 91 by 100. 91 is not a prime number. It can be divided by both 7 and 13, but 100 cannot be divided by them. So this is the most simplified fraction of 0.91. Let's see some examples of 3 digits. 0.113 equals 113 over 1,000. So when you see 3 digits, you just put this number in the numerator, and the denominator is 1,000. And if you can simplify it, you must simplify it. In this case, you cannot. 0.225 is 225 over 1,000. And if we divide it by 25, you get 9 over 40. This is the simplified fraction. 0.367 is 367 over 1,000. Cannot be simplified in this case. 0.488 equals 488 over 1,000. And if we divide it by 8, we get 61 over 125. 0.544 is 544 over 1,000. Divide them both by 8 and you get 68 over 125. This is the simplified fraction of 0.544. 0.656 is 656 over 1,000. Divide them both by 8 and you get 82 over 125. 0.711 is 711 over 1,000. It cannot be simplified. 0.845 equals 845 over 1,000. Divided by 5, both of them, you get 169 over 200. 0913 equals 913 over 1,000. Cannot be simplified. This is the simplified fraction. And that's it. I hope you like it. See you in the next lesson. Hi everybody. In this lesson, we will learn how to convert recurring decimals to fractions. So in previous lessons, I taught you how to convert regular decimals to fractions. Just an example, 0.113 becomes 113 over 1,000. And 0.225 becomes 225 over 1,000. And this can be simplified, and it should be simplified, to 9 over 40, etc., etc. All these examples we've already seen in previous lessons. But today, we're dealing with recurring decimals. So we're going to learn how to convert these with one digit which is recurring, and these as well with 2 digits which are recurring, and also 3 digits which are recurring decimals. And we'll also learn how to convert these where only one digit, the last one, is recurring and the others are not. So let's start with 0.2. Well, the trick is very simple. All those who have one digit after the decimal point becomes 0.222 in this example becomes something over 9. So how do you know what is the something? By the digit itself. In this case, 0.2 becomes 2 over 9. 0.3 is 3 over 9, which can be simplified and should be simplified to 1/3 or 1 over 3. 0.7, well, is obviously 7 over 9. And 0.8 becomes 8 over 9. This is for one digit, and it applies to all the one digits which are recurring. So 0.1, when the 1 is recurring, it's 1 over 9, and 0.4 is 4 over 9, etc. Now, all the ones which are with 2 digits, such as this one, 0.23, when the 23 is recurring, not just the 2, not just the 3, the trick is similar. It's this number over 99. So 23 over 99. And for 36, again, it's something over 99. How do you know what that something is? By the 2 digits which are recurring. So 36 over 99, which should be simplified by dividing it by 9. 36 divided by 9 is 4, and 99 divided by 9 is 11. 0.81, where the 81 is recurring, is 81 over 99, which should be simplified again by dividing it by 9. 9 over 11, that's the answer. 0.94, where the 94 is recurring, is 94 over 99. It's very simple. Well, you guessed it right. If it's a 3-digit number which is recurring, such as this one, 0.243, is the number over 999. If it can be simplified, then it should be simplified. So in this case, we'll divide it by 27 and we'll get 9 over 37. 0.347 is 347 over 999. 0.813 is 813 over 999, which should be simplified by dividing it by 3. So it's 271 over 333. 0.937, when the 9, 3, and 7 are recurring, is 937 over 999. As you can see, it's very, very simple. But what do you do in these cases? 0.2 and then the 3. Only the 3 is recurring. And 0.37 and only the 7 is recurring. 0.81 as opposed to the 0.81 where these two digits, the 8 and 1, are recurring. 0.81, 81, 81. In this case, only the 1 is recurring. We'll see how to deal with it. And 0.95 where only the 5 is recurring. How do you solve it? How do you simplify it? How do you convert it to a simple fraction? Let's see. Let's start with the first one, 0.23. So what we'll do is we'll split it into 2 decimals. One is 0.20, which is the same, and 0.03, where 3 is recurring. It's the same as saying 0.23, where the 3 is recurring. The same thing. Now we all know that 0.20 is 0.2. So this remains the same. And we all know that 0.2 is 2 over 10, which is 1 over 5. The recurring decimal remains the same. Now we'll write it in the following way, and we'll use a trick here. We'll multiply this recurring decimal by 10 and divide it by 10. As you know, if you multiply a number by another number and divide it by the same number, the original stays the same. So in this case, the 0.03 is multiplied by 10 and divided by 10, like multiplying it by 1. We don't change anything. Its value doesn't change. So why do we do that? Let's see why. 1 over 5 stays the same. And now we'll multiply this one by 10. And for that, as you know, you need to move the decimal point one step to the right, so it becomes 0.3. But we still need to divide it by 10 if we don't want to change the value of this number, and we don't. Now, let's write it a little bit differently. 1 over 5 plus 1 over 10 times 0.3, where 3 is recurring. 1 over 5 plus 1 over 10, 1/10 of, and now we'll use another trick. In the beginning of the lesson, and in previous lessons, we mentioned that 0.3, where the 3 is recurring, is actually 1 over 3, 1/3. So we can replace this 0.3 recurring with 1/3 here. And now we suddenly have a sum of one fraction, one simple fraction, simplified fraction, with a multiplication of 2 simplified fractions. No more decimals, no more recurring. It's a simple exercise which we can solve easily. 1/5. 1 times 1 is 1, and 3 times 10 is 30. So we get 30 in the denominator and 7 here in the numerator, and that equals 7 over 30. So 0.23, and only the 3 is recurring, equals 7 over 30. As you can see, it's very simple. Let's see another example. 0.37, and only the 7 is recurring. So we write 0.30 plus 0.07, only the 7 is recurring, and 0.30 is 0.3, it's the same, and 0.3 is 3 over 10, and the 0.07 recurring remains the same, and we write 3 over 10, and we'll use the same trick from before. We'll multiply it by 10 and divide it by 10. We get 3 over 10, and this one again, the decimal point moves one digit to the right. So we get 0.7. 0.07 times 10 is 0 times 0.7 recurring, divided by 10. 3 over 10 plus 1 over 10 times 0.7 recurring. And again, we'll use what we learned in the beginning of this lesson, that 0.7 recurring is actually 7 over 9, 7 ninths. And again, we have a sum of one simplified fraction and the multiplication of two others. Very easy to calculate it. It's eventually 34 over 90, which can be simplified and should be simplified to 17 over 45. We divided 34 by 2 and the 90 by 2. Very simple. So 0.37, where only the 7 is recurring, equals 17 over 45. Let's see another example. 0.81, and only the 1 is recurring. 0.80, I think you got the point by now, but I'll show this example anyway. 0.8, 8 over 10. 8 over 10 is actually 4 over 5. You divide the 8 by 2 and the 10 by 2, you get 4 over 5, 4/5. And this equals 4 over 5. And again, we do the trick of multiplying it by 10 and dividing it by 10. And again, 0.01, where the 1 is recurring, becomes 0.1 recurring, divided by 10, which is 4 over 5 plus 1 over 10 times 0.1. And again, we'll use the trick because we already know that 0.1 recurring is actually 1/9, 1 over 9. And this is very easy to solve. It becomes 73 over 90. It cannot be simplified further. So 0.81, where the 1 is recurring, equals 73 over 90. 0.95, or the 5, only the 5 is recurring, same concept. 9 over 10 plus 0.05. Multiply it by 10 and divide it by 10. And we get 9 over 10 plus 1 over 10 times, and we'll use the trick again. 0.5 recurring is actually 5 over 9. And we get 86, eventually 86 over 90. We divide them both by 2, and we get 43 over 45. So 0.95 recurring is 43 over 45. See you in the next lesson.